find the surface area of a cube, the important thing to remember is that it's made up of 6 square faces. The easiest way to remember that is that you've got a 6-sided die that you would use in a board game, and all the sides are exactly the same size, and there's 6 of them because the die is numbered 1 to 6. So folding this shape out, now that we know that, results in this. You can see we've got 6 squares, 1, 2, 3, 4, 5, 6, and they all are of length and width of A. So if we wanted to find the area of one of these sides, well, it's just a square that is A by A, so the area of one of those is A squared. But we have 6 of them, so we're going to times this by 6. So the surface area of a cube is just 6A squared, where A is the side length of the cube. Cuboids are relatively similar. They look a little bit like this, but notice how X, Y, and Z are all different lengths in this case. We can still fold it out into a relatively similar shape, like this, where you can see we have 3 pairs of rectangles. This rectangle is the same as this rectangle. This one here is the same as this one here, and this one here is the same as this one here. So focus on each pair separately to start with. If I'm focusing on this pair here, let's call it this pair number 1. They are a rectangle that are Z long or Z tall, and they are X wide. So the area of one of these is XZ. Focusing on pair 2, so we'll call this one pair 2. They look a little something like that. We know that they're Y wide, and again, they're going to be Z tall. So the area of one of these is YZ. Finally, pair 3, they're going to be X wide, because notice they're the same width as pair 1. And then they're going to be Y tall, because they need to match up with this side here. So the area of one of those is XY. So our total surface area then, remember we have 2 of each of these because we have a pair of them, is going to be 2 lots of XZ plus XY plus YZ, where X, Y, and Z are the side lengths of the cuboid. A prism is a type of 3D shape with a constant cross-section. What I mean by that is, looking at this shape here, this is a triangular prism. If we take a cut at any point, it ends up being a triangle all the way through. So if we just cut it sort of there, you can see we get a triangle. On either end is a triangle, and so on. So it's got a constant cross-section. To find the surface area of this can be a little bit tricky, but the key thing to do is try and imagine folding it out into its net. That results in this. You can see we have 3 rectangles, one here, one here, one here, of varying sizes, but they all share the same length, L, which is just the length of the prism. So we have 3 rectangles, they're relatively easy to find the size of, and then 2 triangles, a little bit harder to find the size of, but still not too bad. Those are of height H, and then in this case of width Y. So, working out the surface area for this prism, bear in mind this is a triangular prism. You could also be asked about trapezoidal prisms and so on. Finding the surface area of this one, let's focus on this rectangle first. It is L wide and X tall, so that's XL. This one is L wide and Y tall, so that's YL. And the last one, following the same pattern, is going to be ZL. Then we need to figure out the 2 triangles areas. Remember, these are going to be exactly the same because they're both cross sections, and as we discussed earlier, these have a constant cross section. So we have a triangle of height H and base Y. Remember, the area of a triangle is a half times base times height. So in this case, it's going to be a half times H times Y. So a half HY. Putting this all together, we're going to have XL plus YL plus ZL. And then remember, there's actually 2 lots of this because there's one triangle here and one triangle here. So plus 2 lots of a half HY. And of course, we can simplify this slightly because you've got 2 times a half. So it simplifies to XL plus YL plus ZL plus HY. Another form of prism is a cylinder. So to work out the surface area of a cylinder, we're going to need to find its net again. That looks something a little bit like this. You can see you have the circle from either end, because those are constant cross sections again. And then we have a rectangle that forms the tube. So you can imagine like a cardboard tube, like what wrapping paper comes on. If you cut that with one straight line along its length and fold it out, you end up with a rectangle. The length is just the length of the prism, but the width is a little bit trickier. That needs to span all the way around the circle. So that means the width of it is the circumference of a circle, which we know is 2 pi r, or pi d, but we're going to work in terms of the radius for now. So that means we have a rectangle that is 2 pi r by L, so the area of it is 2 pi r times L, which for now we'll just simplify to 2 pi r L. Then we have two circles, one here and one here. They're identical, so each individual area is going to be pi r squared, but we've got two of them, so we'll times that by 2, and we get 2 pi r squared. Then we just need to put this all together, and that results in 2 pi r squared plus 2 pi r L, which you can factorize a little bit to make it a little bit easier to use, and it will become 2 pi r times by r plus L.